Well, hi and good morning, and thank you for joining me here in my shop. Today is July 11th, 2023, and I'm just getting started on the radio you see on my bench there. As usual, I don't know an awful lot about the condition of this radio. I can't remember if I was told it works to some degree or not. I don't recall. So we're going to take a look at the radio. We're going to inspect it, kind of top and bottom, look the whole thing over, and we can start right here with some documentation that the owner of this radio has dropped off. Here we are. Service bulletin. For members of the radio manufacturer's service, a Philco service plan. Well, I'm not actually a member, but I've got their information here. So let's see, model 38C7, code 2124, code 20. So a couple of different versions of this radio. This is the information we've got. We've got the schematic here. Very good. We'll look at all these things more closely at some point. This is the parts layout. It's showing all the different resistors and components. It's a very, very nice diagram. That's fantastic. Very helpful stuff. The replacements listed in this bulletin must be used to obtain the accurate, balanced performance built into these Philco models. So, accurate, balanced performance. That's what I'm going to be after when I'm working on this. Philco Products Limited, Toronto. Toronto almost looks like it's written in separately. Something funny happened with that. This is the alignment sheet. Lots of words in the alignment sheet. And then here's something you don't see too often. This is actually a service bulletin issued sometime after the radio went out. And Philco Projects Limited, Service Department, February 1938. Just a typed up sheet. Volume control, tone control, wave switch, pattern. I'm not sure what all those are about. We'll just take a glance at these. All code 121 sets were run number 1. Shadow meter. Shadow meter. Ooh, there's no shadow meter in this radio, is there? So a shadow meter is a very, very I think it's a problematic technique for showing the signal strength. I don't see such a thing on this. Oh, so I don't know what they're talking about there. Cable added, condenser added, bezel plate removed, shadow meter clips. Shadow meter clips. So I'm going to guess in the original version came out with no magic eye and no meter. There were no indicating meters for signal strength back at this time. So one technique was the magic eye, which you're probably familiar with. The other one is called a shadow meter, and it's basically a beam of light coming through a device which rotates a little bit when current goes through it, and this results in letting more or less light through. That's kind of how that works. Kind of. I've only dealt with one of those. I'm pretty sure there's not one here. So let's just take a look here. I'm missing a knob. Well, oh boy, did I lose the knob? Not. This is the band switch here. Is it just a two-bander? So we'll look at the dial plate more closely in a moment. This is probably tone and on-off. That'd be my guess. Okay. Why don't we take a look right at the plate here. The plate in this radio, the dial plate is an issue. Now, it looks like there's light reflecting in the back there, but that's not. You know what that is? This pointer was sitting in this position for years. And then for a while it was sitting in this position for years. And now, of course, I think, who's tuned it? I've tuned it. Oh my gosh, look at this tuning. Wow, this is something unusual here. And this just turns freely. Man, this is spring loaded here. Wow, maybe there's something to it. know, but it feels like this is how you tune it. You just do this. Doesn't seem to lock or anything, but it's. Well, I don't get this part here. So these just seem to turn freely, just so you can do that. Look at these. Oh. There, I got something. Oh. Oh. Right in. That's why this is spring loaded, so it's always pushed to the front here. Why the two size knobs? Why would you bother with that? This might be a finger guard. When you grab this, your fingers don't go up against what? This was a complicated little mechanism here. It doesn't look like it, but there's a little toothy part back here. Wow, that's quite the deal they've got in there. I mean, it's simple in operation, but so back here we've got like a universal kind of joint to allow for differences between the plate and the chassis, I guess, mechanical differences. Oh, that's a piece of metal in there. It looks like leather. These two pieces here look like leather. There's a great big counterweight here, which is what's giving this the really nice feel. The thing about tuning a radio like this is you've got to tune it very, very precisely. How do you get the precision going? And then this whole unit is like in its own little can here, which is a little unusual. This looks like the light. Up here, yeah, that's definitely the light. The light? Is there only one light? Looks like it. It almost looks like it's inserted. It's got to be inserted from inside. You have to get into this because the glass bulb is bigger than the base. It can't come out this way. Maybe there's a little more to that too. Maybe this comes off pretty. Oh, whoa. So this cowling here is just held by a couple of, it's actually screws down here. Yeah, wow. Nice big piece of felt here. The felt perhaps sliding against the wooden cabinet. It's full of, I feel like staples back here. Yeah, there's a staple right there. I don't know what this would push up against. The staple would push up against it too. There's some very fine adjustments here of some sort. When you're tuning the radio, of course, all you see is the front here. You can't see these guys. I'm guessing these are what these mark certain stations, I'm guessing. And you tune in close, and then you push this in, and it just kind of centers on this pyramid-shaped pin. What a weird arrangement. You have to do this blind. How do you relocate these? Somehow this thing grips them and moves them around. I don't want to move any right now. Okay, it's all gears, no string, and the action is fantastic. It's quite smooth. A little tight in the top end here. Ooh, what happened? It really got tight. Uh-oh. What's happened? Something just happened. It went from being loose as can be to being all locked up. Oh my gosh, what happened? That ruined it already. Oh my gosh. Well, okay, enough of that. We'll leave that alone for now. Good idea. Leave that alone. So we have a tube in a can here with a grid cap on it. Grid cap wire is inside the can with the tube. Over here. A nice shiny tube here. So there's a screw. This is wiggling. And there's a, you know what? This is a replacement tube and a replacement socket. I can see the original socket outline through here. It's held on by two screws, but they're not even the same kind of screw. Here, let's tangle it up here. So somebody's made an unfortunate attempt at soldering the outside of this tube down to the chassis. That's not necessary, because there's a pin. This has also been replaced. Can you see? There's a pattern. You can see where the old tube socket used to be, and if you look, you can see a hole where a screw or rivet must have gone through in the back there. And somebody's come in and put this kind of tube in, and for some reason they didn't. Like, this outer shield is usually hooked up to pin 1. You just have to connect to pin 1 and you've connected to the shield. You do it underneath. There's been no attempt to solder this guy in. But look how loose it's come. Oh boy. Huh. Okay, so somebody's really been at this guy now. One of the things you've probably noticed already is this is tipped over. That's also not a very good sign. Probably the nut is missing here. Probably not a problem in itself. So, they had to extend this wire down to here because the original tube was probably this tall. The original tube here would be this tall. Kind of surprised there's no ground. Oh, wait a minute. There's another tube hidden back here. They also do a big job on this one. No, they did not. So I can see the rivets, and it looks like the original everything. So notice this capacitor has a cardboard piece here keeping the bracket, which is screwed down to the chassis, from touching this can. That's a warning. Could be a voltage on this can. And it means the replacement of this capacitor is not totally straightforward. Just a little bit has to be looked out for. So the capacitor, the tuning capacitor, the two sets of plates are the same size, which means there's probably a series pad trimmer capacitor involved. That's good. What else can we see from the top here? So we already know somebody did a lot of work to it. We also know somebody has bunged up the tuning here and got it all stiffened up. Who did that? Who did that? This thing's up on these rubber mounts here, or whatever this brownish, clearish material is. I see quite regularly in old radios. But it cracks wherever it's been strained. So you see it's all cracked here. But it's rubbery down here. Small transformer suggests it's a 25 cycle radio. Let's see what it says here. 50-60 cycles. It's a 121. That's the voltage. And this is the I can't read the 70 watts. I can't read that little thing there. Let's just get the other camera out. Make it a little easier. .38C7. 38C7. Okay. We look on the sheets here. 38C7, code 121. 38C9, code 121. So this is the 38C7, code 121. So there could be hints all through here pointing to that, like here, like this kind of stuff. The speaker is an H31 or a K41. H31 or a K41. Good luck finding those numbers on here. I don't see them. There's some interesting writing here. Well, I can't make it out. It looks almost like somebody signed their name on the speaker. Okay, let's take a closer look at that little deal there. See a little wire sneaking out from underneath the tube. So what is going on there? Where was it made here? It says made in Canada, Toronto. Do you need a license? Non-commercial reception. Licensed by the Canadian radio pads. That's the radio itself. Looks like they're not demanding a license here. Approved by the Hydroelectric Power Commission. You can plug it in the wall. That's what that means. You can plug it into the hydro system. I don't know how common the word hydro is for electric power, but here in Canada, certainly in Ontario here, because we're so close to Niagara Falls, electric power is called hydro. We call it getting the hydro. Oh, a little note here. $425. Whoa! 1938 Philco. Well, this power cord has clearly been changed. It's not the original. Let's look underneath, see what we got here. Who's done what? So, having done these tubes here, hard to say what might have been done underneath. Let's take a look. Let's see. Ooh, careful there, man. So this piece up here is really, really heavy. This is really unbalancing the radio. It's really strong here. If I flip this guy right upside down. Okay, bad things happen at this moment. Oh, right like that. Upside down. You go. And then how can I keep it like this? This will be. That's a little questionable. That's just a little questionable. That's really just as questionable. There's nothing here holding this up. This may not work out very good. Oh boy, oh boy, oh boy. Don't anybody move. Okay, as long as I don't do anything dumb, it'll be okay. I won't do anything dumb. No, you can be sure of that. Well, right away, full of old capacitors here, all over the place. One in here. There's a whole pile of them over here by the volume control. Lots of old wax capacitors. What is this? What is this action here? This is a horrendous tape job, but when you use this kind of tape, and don't use this electrical tape, to make this tape work, it must be stretched as it's applied. You have to pull it a little bit and then apply it. If you don't, you get this. Schmozzle. And there's a wire coming up out of the capacitor that's got the cardboard insulator on it. And the wire's insulation is gone from here, right where it comes out, gone up to about here, and then I don't know what the kind of made a connection and taped it all up. Phooey on that. We're almost certain to replace this capacitor anyway. You can see a big one over here. So what's this one doing over here? This could be doing the same job as this one, and the guy doing this realized he could locate it over here nicely. So this is a ground terminal. It's a rivet. It's a riveted arrangement. The rivet looks really good. And we have a capacitor just in here. Offhand, we can't really be sure what it is, but we could be pretty sure. filter capacitor. Maybe not. It could be a bypass capacitor near the output tube. And where is that output tube? Okay, so here's the loose. Oh, what has happened here? This is all covered with black tar. The insulation is missing here. It's missing here. And here. You know what it looks like? It looks like, for some reason, I don't know what that would be just yet, all these wires have been exposed here. They're all somebody went in and chipped away the insulation on this, every wire going into here, through the square hole up into the IF. And this is the loose IF. So somebody has, what they've done here, I think, is they may have cut these wires, taken the IF transformer out, done something to it, and then put it back in. And in the meantime, they lost one of the nuts, and so they just put it in one side. Unfinished work like this is a bad sign that somebody gave up on something. It looks like this black stuff is an insulating compound, like a paint. They painted over it to re-insulate all these wires, which I've never seen that before. But it's a, you know, if you had the right kind of painting material, that would be a pretty effective way to do this kind of thing. That's my guess as to what this indicates. Trouble in this IF, and somebody removed it. Now, cutting the wires here is kind of dumb, and they might have realized it afterwards, because you've got almost no room to work in here. As for any of these wires being shorted or something, I don't think. Well, these two are stuck right together here. The compound is glued, this white wire and a red one right below it, and but I don't think the red one is cut. And I can't really separate them because this black stuff is really hard. It's like a epoxy. Okay, that's an interesting story. I don't know what will happen when we get there. Now, over here is a wire just cut and hanging out here. It's just hanging out. What are you for? Were you a bad boy and somebody cut you and left you abandoned? So, don't know, but you can take a guess. This is sitting here. Something was here before and is gone now. Oh, we have that diagram. Hey, we have that fantastic diagram. The one that shows the location of all the parts. Here, somewhere. Where to go? You know, there's more than 3 sheets of paper, so I'm getting confused. There it is. Yeah, so this is the way this lays out. So it's pointed, there's a capacitor down below here. You can just see the edge of it way up in there. That's probably this one, number 30. Number 30, oh, this is very helpful. Condenser 0.1, so that's a 0.1 down there. So this does not appear here. You'll look at number 45, which is this guy here. 45 is electrolytic condenser. That's all it says. Electrolytic condenser. Okay, so this guy is showing up from somewhere. Who knows where. I'll have to sort that out down the road. Okay, I'm just noticing now some coils right here. Coil here, coil here. So some fine wires in here, right here. Don't break them. That's what I'm getting at. Some kind of a rubber thing here. Why would they put that there? Like a bumper. Something moving? Big high wattage resistor here. And what's this? What's this thing? Hey, what is it on here? So this? So you got a tube and a tube. You got this plate with a corner. Plate with a corner, tube and a tube. It's this thing. No, this is a hole. This is a hole. And would these be the wires going into the hole? And then this thing, I don't know, it's not appearing on here. Is this it? No, this is this. And this resistor's this. What is this? What is this thing? Come on. Really? This is almost life size. And the resistor capacitor here. Well, that's a mystery. Maybe this thing is described somewhere else. So that's an insulating piece. We have a lead connected to this terminal, which is connected to like a center pin, almost like a light bulb deal. Screw going through the middle here, probably the same screw. So this cowling goes to ground. You know what? I got no clue what this is. That's a weird thing. Wow, I don't know. Very odd. What other weird things can we find in here? So here's the power cord coming over to a capacitor block. Inside this black thing are some capacitors of some sort. And then this is full of compound, black tarry compound. So almost certainly this one here is a capacitor right across the power line. Let's see how they do the power. It's worth becoming a little conscious about some of this stuff right now. So we see power cord coming in, and we see capacitor and capacitor to a wire going to the chassis. This is going over to the switch. Here's the switch. Switch is gained. It's the same switch. They just spread it out on the page here. This is actually part of this. You're switching on, and then you're selecting tones. So the wire going to the switch right here, then coming back from the switch, going to the primary of the transformer, and then going back to the other side. But in the midst of it is this connection here. So it could be achieved. This could be the ground terminal, if you like, and you could run a wire maybe from here, but there's no wire. Looks like there's never been a wire there. And why the two posts? Because this is one continuous. I just realized this is one continuous piece. I thought it was a lug. Four. It's only two. So there's an in and out to make easy connections. And then there's going to be a capacitor from here, a capacitor from here going inside to this terminal, which is the ground, which is to the chassis. So there's a chassis connection to the plug direct through these two capacitors. You have a short in one of these capacitors, and you have the chassis connected directly to one side of the power cord. The power cord is it's polarized. We don't know what went on inside. Can we figure that out? I don't think you can be sure where, which one of these is hooked up to which one of these. I have to pop this apart. Take a look. Do that right now. You do it other ways. Use a meter to do it. So because this plug is polarized, the hydro system or power system ground is brought in always on the same wire, whichever one it is. And I don't know which one it is. Does it really matter? Sometimes it's just good to know what the situation is in case it matters down the road. So these wires are all pretty stiff. They're not complete. Oh yeah, they are pretty darn stiff. So when it comes to working on this guy, we can't be doing too much movement, and maybe that's why this ended up this way. The guy felt he couldn't bend these wires or do anything with them. The best move was just to cut it all in here, kind of leave it all in place, and then when you put things back together, everything's still there, because you can't be swinging these wires around. You're going to crack the insulation on them. So lots of capacitors to replace. Components, we don't know what they are. Maybe you might know what that is. I don't know what that is. Almost looks like a battery holder. There's no battery. So occasionally these radios have a battery right in the back of the radio. It would be in the parts list if it exists. Once again, it's too many pages. 3 pages, I'm okay. 5. Is there a battery in here? Cabinet parts. Dial, knob. Corner, rubber, bracket, socket, vernier drive. Description. Oh, this is all over the place. Condenser, tuning condenser, oscillator, transformer. It's not capacitors, resistors. It's not done like that. So I'm not going to stare at this so carefully. I could easily miss a battery. Audio shorting switch. Part of selector crank. Well, this is on the 38C7 only. But this is a 38C7 I have in front of me, isn't it? Is that what we're dealing with here? So what did that say again? Audio shorting switch. Part of selector crank. Audio shorting switch. So it shorts out while you're tuning? You don't get, I don't think so. Audio shorting switch, okay. Don't know what that is. Continuing down, looking for a wave switch. Pilot lamp. No, I don't see any battery in here. Doesn't mean it isn't a battery. So they put a battery in a radio like this to provide some negative bias to a grid on a tube. The kind of battery they use basically would last the life of the radio, but look, where the radio's still here in 2023, which would blow the heads off the guys who designed this or built it or anything to do with it, sold it, anything to do with this radio. If they could have just propelled themselves to now, then I think they would fall down. Is that what's going to happen to us? Is that what is happening to us? We are falling down on our knees, crushed by the technology, which is just happening so slowly. We don't actually have to fall down to our knees, but mentally or emotionally, that's what's happening to us as human beings. We're crushed by the technology we love. Well, I think that's about all I'm going to pick out of here. Looking at this at the bottom, here's the antenna connections here. Let's take a look at those for a minute. Here's bits of like a brush that somebody has been in brushing. And out have come some bristles. And you know what? Maybe it was the brush he used to paint this black stuff, because these bristles are stuck to the side with the black stuff. So that's what that is. He used a little brush. So, okay, on here. What do we got? Do we have some letters? We do. This is red, black, and ground. There's no link. That could be missing. Could be missing its link. Let me go back up a little bit. Oop. Standing on the wire. So we have these two, which are wound together. This one would appear to be connected to a grounded terminal here on the chassis. Well, this didn't say ground. This said black. This said ground. So this one's going the other way. Where's it going? And it's kind of disappearing from view underneath the. I think it's. Oh, these are all so stiff. Give me a stick. Jeepers creepers. Tricky wire. Where's it going? Oh, it's way over to here. It's all the way to here, and here it's meeting up another terminal strip, and this center post is crimped to the to the chassis, and you know what that means, I'm sure. So why all the way over here though? From here, when surely that you can go down to here. You can go. There's probably other terminals very close that you can go to. Why go all the way over to here to get onto the chassis? So this one's called ground, but then I followed this one also going to ground. It's the same. It's a chassis thing. Why? So typically, I see red and black marked on here, and then another terminal that says ground. This is reserved for loop antenna. Loop antennas come with 2 wires. On they go, and then the loop antenna feed is usually supplied to a transformer, not down to the chassis. That's not typical, I don't think. What's it show? We got the schematic here. So here we are. So red, black, ground. Let's follow the ground. Yeah, there's a long wire. You even show it here as a long over to this point. They've selected this point, and there's the ground there to the chassis. Not by mistake that they've brought it all the way. Okay, no. I was just about to say, oh, this is a cheater way to make an antenna out of the power cord. No, I don't think so. Not with that connection there. Something to do with hum? I don't know. That's a strange one, isn't it? Okay, now this black one also appears to go to a ground. There it is. There it is, right there. There's a switch here, but the switch doesn't interrupt the ground connection. Well, there's a reason why. These two are here. I don't know what the reason is. And then this one, you would hook up your long wire antenna. I guess you could put a loop here if you wanted. Long wire antenna on here, and then it's working against the chassis. It depends upon the position of the switch whether the signal goes through this transformer or not. And 2 bander, 2 sets of antenna coils. Got the schematic in front of us. Might as well take a quick look at it. field coil in the speaker. So this arrangement here, I guess they're just voltage dropping resistors to provide certain voltages. That's a plate voltage there. 1 meg resistor. Wow. Up here, another 1 meg resistor. A fairly large capacitor here, so they're really trying to really make this grounded here. Another 1 meg here, and that's the audio going into the audio going into the amplifier here, the preamp, and then off to the power amp. Well, we'll get into this in more detail as we work along with it here. Used in model 3087 only. It's a ground connection. How about the filtering? Let me look at the filtering arrangement here. So we have a 8 microfarad and that looks like 25 microfarad capacitor here. And you have the Philco, so it's your pi type filter. This is kind of large. The input size is kind of large here. So we found one capacitor anyway. It's this thing here, which we'll deal with. And so the other capacitor would be this one, but there's supposed to be 2 in here. Oh, well, maybe we can find them on the. Getting better at handling 5 pages of paper. Can we find the other capacitor? Oh, we'll find it this way. And these aren't in any kind of order. So the word electrolytic, I think, is the first word here to show up. Condenser electrolytic dual 4 and 8. That's number 11. Number 11. There's number 11. It's over there. Well, yes, it is. Wires are coming up here. These are pretty flexible. So this is probably a replaced guy here. He's been replaced once. My experience is with these power supplies that use the field coil or a choke, as opposed to the actual field coil of the speaker, the capacitors are not that important in the filter. That's been my experience. So even though this has got old, semi-old capacitor there and something here, it looks like somebody replaced both filter capacitors. They're probably serviceable, but we can't know until we're operating the radio. But that's probably what that means. And so wait a minute now. If there's 3 of them, where I only saw 2 on the schematic. So we got 1, 2, 3, and then this thing. So we can look for a bypass on. There's no There's no cathode resistors in this radio. Cathodes are all down on the chassis. So there's no bypass for that. And we have 1 here, 1 here. Oh, that says 11A and that says 45. It's 11A, where's 11B? 11B. We're now looking for 11B on here. Where B 11B? Look at there's 19B, 19C, and 19D. But that's not 11. We're looking for 11. There's 11. It's electrolytic 4. It's a 4. And we just put it here. Here's another one. Oh, but that's not electrolytic. The electrolytic, they draw like a little box shape rather than just 2 flat plates. They put a little boxy thing on it. 2, 3. Where's number 4? Can we spot number 4? I'm looking everywhere. on here? Do not see it. Okay, so we'll just leave that as a kind of a question mark. Why is there that? Why is that there? It's hooked up right to a very busy pin here, probably a ground terminal here. Not sure though. Don't know. Can't spot it. Still looking. No, I don't see it. Okay, we got a nice diagram of the different coils. That could be helpful. Hopefully we don't need to know that. Switch shown from rear of chassis, bottom view, shown in position number 1, broadcast. That's the switch there. That's all the different numbering on A7, A6, A5, but there's no wires coming from it. So how have they done that? What have they done in this schematic? Like, where's the switch wired in? Or are all the little switch pieces? Here's one. So they got little switch pieces spread all over this diagram, really coming from here. Any more switch pieces? any more? A6, A7. So that'd be A6 and A7. Well, this might be a better way to do it. Looking at this might be easier to interpret than these switches drive me batty working on these radios. Well, I still don't see it. I'm not going to see it for now. Here's a switch only used in model 38.7, only 29, switch number 29. Well, there's definitely some mysteries here. Interesting stuff to consider. Now, should we fire this guy up as it stands, as it sits? Let's see what comes out of the speaker. I didn't see anything in there that made me think, oh my god, this would not be wise to start up. There's definitely some interesting stuff in here, but nothing that's screaming out, don't start me up. Let's just, wait a minute now. Let's do this right. Get rid of these wooden blocks. Yeah, let's do it right. Let's do it right. Let's not do it wrong. Okay, over you come. Oh, this is a heavy son of a gun. The weight is all over the place on it. The weight is hanging way out here. This is not helping. Hey, did you come back to life? Are you? What the heck? Oh. Okay, let's just leave it like that for because it's that's all the way one way right there. Yeah, pointer's all the way one way. Well, maybe it's just a little bit of this thing may have slid back and forth a little bit on in here, and it got kind of pinched in one spot. It probably needs a little lubrication. Still curious about what this little thing is here. Great. Okay, coffee time, and then I will consider starting this guy right up. Oh my gosh, I've been going for 50 minutes on it already. Okay, I think we can try starting this guy up. Let's take a look at the speaker here. The speaker phone's got a couple of repairs on it here. These speakers tend to develop cracks, kind of radiating out from the center, right around the outside here. Now this is odd. There's a big gap here, and it's been left. It's right from the manufacturer. Looks like. Well, you don't want a gap in your speaker. So you're trying to push the air into the room. You don't want any air shooting through a little hole like this. But otherwise, looks pretty good. That's pretty minor damage. I've seen them far worse than this. And surprising to me, these old speakers tend to survive. Somehow you'd think the paper cone and everything, they wouldn't, and I guess some don't. So these connections are taped here. just possible this has been replaced or something else has gone on, but let's not worry about that. So, practicing now. Off, on, tone, 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 tone. Off. This would be the band switch, 2 bands. We'll assume that that's the AM band. And volume, which will turn up just a wee bit. So the way I would start up a radio like this is not plug it in the wall and let Niagara Falls have its way with it. Instead, I would restrict the power, and the way I do that is very simple. I use it's a well-known method called the dim bulb method. These are my 2 incandescent light bulbs here. When I first turn on the radio, I will direct the electricity through the light bulbs to get to the radio. If the radio has a short circuit in it or something really bad like that, the lights will come on bright. They just stay bright, and I'll know right away. And I'm saying lights because there's 2 bulbs in here. I can unscrew one and then just force the power through the other light bulb. If I have a much smaller radio, I would do that. With a big radio like this, use both lights. The voltage ultimately reaching the radio, at the very instant of turn on, it's going to be 115 volts or whatever, but quickly drop down to 50, 60 volts. And these lights will be fairly bright while these capacitors charge up. Then the brights, once the capacitors are charged, which should happen pretty quick, so see the lights will go bright and then come down like this. Then they'll sit for a bit and start going up as more and more power is being drawn by the radio. The rectifier tube starts operating, and the other tubes start to conduct current. So you get a up, down, and then an up. On the way up, the volume should show up. That's how it should work, just based on those lights alone. So I kind of like the lights. I like the lights. I also have a much better, in some respects, a much better way. I have this control. I can change the supply voltage ultimately. And also, this plug I'm using here on my bench goes through this guy, which is an isolation transformer, through another isolation transformer. Aren't I crazy? I'm crazy. Multiple isolation transformers. So there's no ground reference here. Whoops. If this chassis were to be live at 120 volts, I could put my hand on it and stick my foot on the floor here, although there's no way I would ever do it. Absolutely no way I would ever demonstrate. See, you can't get a shock. No, that's not a good demonstration. I didn't really talk about this back plate, but it's really worn very roughly up in here. It's in pretty rough shape, unfortunately. I'm not sure what we can do about it, but if anything, I wouldn't want to make it any worse, that's for sure. Okay, so we're all set. We're set, so the set, yeah, all set. Set is off. I'm going to apply power, and what should happen is basically nothing should happen, but you'll see this meter here jump up. I'll explain that in a moment. Here we go. Okay, so this guy is, we're a little low on the voltage here. Let's put it up. You can look here and find out what the voltage is. 109 volts. Just a little down. There's nothing happening in the radio because the switch is off. That's good. Some of these radios, the switch is broken, and they're on all the time. Okay, 113. That's the max. Now I am sending the electricity through the light bulbs, but there's no load except this little meter here. So there's no voltage drop. So now I'm going to turn off the power here. And going, by the way, this meter starts at 100 volts here. So anything under 100 volts looks like 0 on here. So I'm going to put this on one snap. And here we go. Now this time the light should do what I was describing before. Bright, down, and then back up, down. Woo! Up and down, up and down. Too many ups and downs. So nice light came on here. Beautiful. Lovely. Actually, it doesn't look as bad when the light is shining through it. The card here. And we're waiting for action. Now there's nothing hooked up as an antenna. And in some of these radios, with no antenna connected, they are stone silent. So I'm going to connect it. this lead, it's actually not really going anywhere. Okay, we got 80 volts on it. Can you hear that? This radio's working. Okay. It's got some good volume. Yeah, this radio's working. Oh, went a little quiet there. What is going on with this? It's a very complicated mechanism back here. There's more to it. There's more to this. There's a sliding contact down in here. And then there's this dark plate here. It has rivets periodically on it. And it almost looks like contact points. As if there's a slider sliding along, going to contact these different contacts. For what purpose? And there's many of these little pins. There's many of them. There's a whole file down the bottom here. 1, 2, 3, 4, 5, 6, 7, 8, 9. So these are ones. Look at this, is loose. So these are ones that have never been set. Aha. So you just screw them. Well, how would you do this when you're operating the? Oh, you gotta be kidding. Would you actually grab it with this tool? This is like a. Can you go in? Well, there. No, there's no drop. Maybe here. You actually stick a screwdriver in here. This is on, Jim. Don't forget. And then the screwdriver will drive this piece loose back here. Oh, come on, really? That's what they did? Why else would they put this big inviting thing on the front here? Yeah, sure enough. When you turn this, you turn the whole thing. Okay, I won't do any more. I think I'm figuring that out. Probably in the instructions, and if I took the time to read them. But sometimes it's more fun to just play around, pull it back out. It still has this very odd little, yeah, that's a good description, a little piece in there. Woo, what was that? It's right at the end of the run. Can we pick anybody up? So I think I'm on broadcast, and we would want to go right around this. Oh, look at this. It's got the actual stations written here. CFCF. I don't know where that is. WEAF. WLW. That was a North America wide station. It was on a clear channel, so he could broadcast right across North America. WLW, there's quite a few stations that were on clear, what were called clear channels. That was some kind of agreement between Canada and the United States over North America, where we would pick certain frequencies and say, okay, we're only putting 3 stations on that frequency, one in California, one in Florida, and one in Toronto, something like that. So they'd be so far apart that they could still operate. Whereas most AM frequencies have had, 100 stations on them or more. Okay, enough of that. Okay, we're not really on an antenna here that's of any use. This is very difficult to tune like this. There must be more to the tuning than just grabbing this thing and doing what I'm doing, because maybe I'm going to attach a loop antenna to this. Let's go on the short wave band and see what's happening. Now, what time of day is it? Oh, I'm still operating this thing with 80 volts. Ooh, 80 volts. Let's give it a little more. Still low at 90 volts. That's still low. Give us a little more volume, probably. Short wave. Oh, did I already flip it? Duh. So we're at 8 megahertz coming up on 9 megahertz. Full volume. So station rate around 9.3 usually. But you know, you need an antenna hooked up. I think those are my lights. Yes, that's the lights. I use this power supply to drive the spotlights on my bench. Okay, you can see the dim bulb lights are quite bright now, and that part of that is I turned the voltage up here to drive the voltage over here. So we're still low though at 90 volts. And the number of watts, this is a 70 watt radio, is it? So when operated at 90 volts, it's only 40 watts. That makes sense. Nothing here to be, I don't smell anything burning, nothing to worry about. Let's improve this antenna. So I'm going to stop for a minute and run and throw a switch. Okay, so this is now connected to an outdoor antenna on a very, very long antenna lead. Very tricky to tune this radio. Around 11 megahertz here. The radio's getting louder as we go. Right around here, station. Down around 8 megahertz. We're not going to get anything that low. Up around 15. Pretty quiet. That's full volume too. What I'm going to do is I'm going to hook the ground lead of the antenna to the chassis, to the black. Here, we'll just see what happens. Probably get quiet. Let's see. Okay, now I don't think this is going to help. That's full volume, but we're still only at 90 volts. There's nothing at all with that wire connected. Okay. With the antenna, we should try broadcast again. More volume in the broadcast band. Okay, so that's an interference noise I hear regularly in my shop, right in this frequency range here. That's good, even though it's not what we really want to hear. Somebody. Okay, the strongest station is 590 down here. Ooh, ooh. Oh, that's that weird spot we get. Okay, I got one more trick up my sleeve, and that's to use a loop antenna on this. So I'm going to try that, and then we're done, because wow, this is a long video now. Okay, I have a loop antenna hooked up. I'll show you the antenna in a moment. Full volume, but I don't know where the antenna is tuned. Somewhere up around there. But we're chasing stations down around here, so I'm going to tune it to basically 590, and then we're going to tune the antenna and see if, well, it may not have it on 590. There's a strong station there. Tune the antenna here. Hear a thing. Nothing at all. Nothing at all. That's just makes me think I've done something not right here. What dumb thing have I done? No, that's the right lead. Oh, it's popped off. Volume's up. We switch bands. My stomach's growling. Anybody hear that? I'm not sure why this isn't doing anything, but it's not. This usually supplies a strong signal. Do we have time to hit it with a signal generator? Let's do that, because I just want to hear something come right through this radio. Just take a moment to sort that out. Okay, so that's up at 1600. Let's bring it down to, say, around 1 million. That's a moderately strong signal being sent to the radio. 1 million is going to be up around here. So here, and then again here. So there's clearly an alignment issue with this radio, but there it is. Okay, that's great. Now I'm in a position to make decisions around what to do about the radio. I'll just make a few comments right now. Don't hear any hum from the power supply at all. So I think those capacitors that were replaced, I'll leave them alone. The smaller capacitors, all those wax ones, they really should go. And that will probably raise the performance of the radio. We do have the volume up fairly high to make it operate. That might indicate a weak tube, but it might indicate many other things too. So we have to kind of do it sort of one step at a time. But you know, we're just on the verge of checking the shortwave band too. So let's do that, because it just takes nothing to do it. So we're tuned now right around 9 megahertz. So I'm going to set the signal generator up to 9 megahertz. Well, that's just a terrible frequency for me. Let's put it at go up around 11. 11's just easier. Okay, here we go. Volume up. Volume's full. There it is. Okay, we get one signal. One signal. Not like the other band. Okay, that's the end of that. Very good. That's excellent. So one of the worst things is to have a radio on your bench when you're starting and is already working fairly well. Because that, you know, if it's not working well at all, there's only one way, and that's up and better. But if it's already working pretty well, there's two ways. There's up and better, and there's down and worse. And, but I'm not too worried. Very good. So I'll make a plan, and then tomorrow I'll start performing work on the radio to try to improve its performance. Ultimately, I think it's an alignment issue. Really got to wonder about that knocked off IF can at the back there. Got to wonder about that. Very good. Thanks a lot for watching a rather long video, and I'm off to enjoy the sunshine outside. It's a beautiful day. What am I doing in here? See ya. Thanks for watching, and thanks for the super thanks. See ya.